If we sort of connect all this to the bigger picture, it's clear these are incredibly complex environments with dangers coming from all sides. So, how do professionals in fermentation or really any biological field actually go about assessing these myriad risks? And then the crucial part, how do they manage them effectively? It sounds like an absolutely enormous undertaking.
It is a significant task, but it's approached systematically, starting with a robust risk assessment process. The first step is always identifying all the potential hazards. That means looking at everything the biological agents being used, the chemicals involved, the physical aspects of the equipment and environment. A really thorough analysis at every single stage of the process helps anticipate what could go wrong.
Okay, identify the dangers. Then what?
Next, professionals evaluate the potential exposure levels and the likely consequences. They ask, how might personnel come into contact with these hazards? How often? For how long? What are the potential health effects if exposure occurs? What disruptions could it cause to the process or the facility? Finally, based on that evaluation, they determine the overall risk level. They combine the likelihood of something bad happening with the severity of the consequences if it does happen. This lets them categorize risks, maybe as low, medium, or high, and that whole assessment process directly informs what safety measures need to be put in place.
Right. So the assessment tells you what to worry about. How do you actually manage those worries? What are the strategies?
The risk management strategies generally fall into a hierarchy, often starting with the most effective. First, you have engineering controls. These are physical changes to the workspace or equipment to reduce the hazard. Think of using completely closed systems for fermentation, or installing specialized biosafety cabinets that physically contain aerosols. High-efficiency particulate air, or HEPA-filtered ventilation systems, are another key engineering control for maintaining safe air quality. The goal is to remove or isolate the hazard at the source.
Okay, physical changes. What if that's not enough or not possible?
Then you move to administrative controls. These are about procedures and policies. Developing and strictly enforcing standard operating procedures, SOPs that clearly outline safe ways to perform tasks, is fundamental. This also includes things like providing regular, comprehensive training for all personnel, maybe requiring certification for certain tasks, having clear signage, and controlling access to hazardous areas. It's about managing how people work.
And the last line of defense.
That's personal protective equipment, or PPE. Things like gloves, safety glasses or goggles, face shields, lab coats, sometimes respirators. PPE provides an essential barrier between the individual and the hazard. But the key here is consistent and correct use. PPE only works if it's the right type for the hazard, fits properly, and is worn every single time it's needed. It's crucial, but it's generally seen as less effective than engineering or administrative controls because it relies heavily on individual behavior.